This part is in continuation with the previous part, function of commutator part 1. So this is part 2. So we were discussing the moment when omega t is 0 degree, and at that time we have seen that the polarities of the EMFs induced in the various coil sides can be shown like this. So we may observe that the net EMF across the terminals x and y, or here x and y, you may observe that the net EMF is E plus E2E plus E plus E 3E plus 4E. This is also E. Fine. Similarly, here also 2E plus 2E 4E. So we are having two parallel paths, and net EMF induced across the terminals E is equal to 4E at omega t is equal to 0 degree. Fine. Now let us consider the case when this rotor is further rotated by 45 degree in the anti-clockwise direction as shown, the moment when omega is equal to 45 degree. Okay, let us take it as 0, the first case. We will compare with the next case, right? So okay, I am going to draw it here. Now we are going to consider the case when this rotor has rotated by theta is equal to, that is omega t, 45 degree further. That is right here, omega t is equal to 45 degree. So at this moment the rotor position is like this. See here, this position has rotated by 45 degree, this also 45 degree, this also 45 degree, this also 45 degree, like this. Make the connections of the coil ends with the commutator segments. So one is connected with A. Okay, so connect one with A, two with B, three with C, and 4 with D. Similarly, if one is connected with A, then one dash will be connected with B. So this is one dash, so connected with B, and 2 dash connected with C, 3 dash connected with D, and 4 dash connected with A. At this moment omega t is equal to 45 degree, we can observe that the two coils, coil 1 and 3, two coils have reached the position of interpolar region along magnetic neutral axis. Hence no EMF will be induced. But the other two coils, coil number 4 and 2, are in north and south regions, you can observe. So EMFs will be induced in these two coils only, 2 and 4. No EMFs will be induced in coil 1 and 3, as at this moment the position of these two coils are along the magnetic neutral axis. Secondly, the brushes connects the two commutator segments, means shorts the commutator segments A with B and C with D. It means the two ends of the two coils 1 and 3 are being shorted at this moment. How? See, one is connected with A and one dash is connected with B, and these two segments are shorted. It means one dash, that is other end of coil 1, is shorted with the first end of coil 1. It means if EMFs will be there, then short circuit will happen and a sparking will be there. That will be not good for the machine. That's why the position of brushes are fixed along magnetic neutral axis. Because no problem, at this moment the two ends of coil 1 as well as coil 3, you can see 3 is connected with C and 3 dash is connected with D, and these two segments are being shorted with the help of this brush. Then at this moment the two ends like this, See, the EMFs are two ends. See, if this is plus, this is minus, if you are going to short it one with one dash, it means short circuit will happen. But no need to worry, as when the brush is going to short the two commutator segments at which the two ends of a particular coil are connected, then at that particular moment when the two ends are being shorted, no EMF is induced in that particular coil or coils, so no need to worry. So that is the beauty of this commutator arrangement. Fine. So let us mark the directions. So this is dot, so direction will be this, and no dot cross because no EMF is induced. This is cross, so direction will be this and this. So here no EMF induced, so no directions. So this is why if load is being connected, not shown here, between the two terminals, then current will flow, and once current will flow, so you may see that the direction will be like this. So you may start from here. So start, current goes to 2 dash, then from 2 dash it goes to 2, then from 2 it goes to this terminal. Similarly, one more path is there. So from through this 4, it will go to 4 dash, and from 4 dash it will go to this terminal. Similarly, you mark the directions here also. Dot means these directions, assuming that load is being connected across the terminal so that current starts flowing, right? So this is cross. So cross means flowing into this. This is cross flowing into this. This dot flowing into this. So start with any negative terminal. Fine. So current flows. Take first blue path. So from blue path it goes to 3. Then it will go to 3 dash, and through 3 dash it will go to this segment which is shorting this terminal, that is 4, and then from 4 it will go to 4 dash, and from 4 dash it will go to second terminal. Similarly, what about the other path? Take the black one. So from here this is 2 dash, from 2 dash it will go to 2, from 2 it will go to commutator segment B, and this segment shorts this 1 dash, so it will go to 1 dash, and from 1 dash it will go to one end, and through this it will go to the other terminal. Fine. So corresponding EMFs induced in the two coils, coil number 2 and 4, may be represented like this. First draw the commutator segments. See, this segment is also being rotated by 45 degree, that's why acquiring this position. So make the same position. So this is your commutator segment position. This, mark the points. This is A, this is B, this is C, this is D. Fine. So make the connections. Just rotate this by 45 degree. So this will be 45 degree. This is 45, looking 45. So rotated 45, it will be parallel to this line, right? Okay. So just draw first these lines. And mark the coils. So this will be 1 dash. So what will be EMF induced in coil 1? 0 volt. Right here 0 volt. Right here also 0 volt. This is back side of coil 1, already written here, right? So 1 dash, then 2 dash. So make this. So this is 2 dash. What about EMFs induced and polarity? So 2 is connected with 1 dash. Where is that? 2 is connected with 1 dash. So no EMF induced in 1 dash, but 2. So plus sign is there, right? So write here plus and minus, E plus and minus, because at 2 dash minus is there. So 2 dash minus is there, cross. So this is also E. Similarly, after this coil is there, 3 and 3 dash. So this is 3 and then 3 dash. So again in coil 3, no EMF induced, right here 0 volt, 0 volt. And the final one, 4 and 4 dash. So right here, so this is 4, this is 4 dash, and what about 4 dash? This is 4 dash plus, right here plus. And what about 4? Cross, so write minus here, so plus, minus, plus. This is E, this is E, this is back side of coil 4, and these are our brushes position. This is X plus minus Y. So in this case, we can observe that the EMF induced, net EMF induced across the terminals is equal to, see here, E plus E, then 2E here also. So again we have two parallel paths, but in this case the EMF induced at omega t is equal to 45 degree is, this EMF induced is 2E only, half of the EMF induced in the previous case when two coils are not inducing any EMF because of their respective position, right? Now consider the third case when omega t is 90 degree. It means the moment when rotor is further rotated by 45 degree. So rotate it by 45 degree, so that earlier these ends were under the effect of north pole. Now in this case these were not in any effect of in any pole, means omega t is 45 degree. Now take the third case when it is further rotated and came down in the south pole region, right? So I am going to draw the corresponding diagram. Now we are considering the third case corresponding to theta is equal to 90 degree, that is from this initial position at omega t is equal to 0 degree, the rotor has rotated by 90 degrees, so that this position may be marked here 1, and similarly 2, 3 and 4. So the corresponding positions 1 dash, 2 dash. So at 3 this is 1 dash, 2 dash, 3 dash and 4 dash. Fine. So at this moment we can observe that the coil ends 1 dash, 2, 3 and 4 dash lie under the effect of north pole, whereas the coil ends 1, 2 dash, 3 dash and 4 lie in the south pole region. Hence the polarities of the EMF induced may be marked as earlier. Whenever a conductor comes in this region, the polarity will be like this. So earlier these ends 1 dash and 3 were in the region of south pole. Now these has come in this region. Earlier 1 and 3 dash was in the region of north pole. Now it has come in the region of south pole. So corresponding polarity may be marked here. We can see that the polarity has been changed from this position. Fine. Make the connections. So 1 is connected with A, 2 is connected with B, 3 is connected with C, and 4 is connected with D. Similarly, 1 is connected with A, then 1 dash will be connected with B. So this is 1 dash connected with B, 2 dash will be connected with C, 3 dash will be connected with D, and 4 dash will be connected with A. 4 dash, when you check from here, 4 dash is connected with A. So with A, 1 and 4 dash has connected. So with A, 1 and 4 dash are connected. Fine. Let loads are connected across the output terminals. So corresponding current directions may be marked like this. This is dot, dot. These are cross. So cross means going into this. These are cross. So going into this. It means current is coming and leaving from this terminal. Fine. The corresponding voltage diagram may be drawn like this. First draw the commutator. So mark the corresponding positions. So this was the earlier position of A. So rotate it by 90 degrees. So this will be the new position of commutator segment. You may observe that brush positions are fixed at any moment of time. Only rotor rotates, pole positions are fixed and brush position is fixed. Only rotor along with the commutator rotates and conductors are placed on the rotor, hence conductors positions are also changing with the time. Fine. So mark this commutator segment positions now A, B, C and D. Fine. Make connections like this. So this is, make carbon brushes. Brushes may be of carbon or graphite or mixture of both. So this is X terminal, this is Y terminal plus minus. Fine. So take one point from here and one point from here. Make the connections. So this position has rotated by 90 degrees. So you may make like this. And this is 1 dash. So mark here 1 dash. So this position will come here. So 2 dash. Here 2. And this is 2 dash. Similarly, this position will come here by rotating this 90 degree. So 3 dash. So this is 3 dash, and then this 4 and 4 dash. So from here 4 and 4 dash. You may check from here itself. So where is 1 dash? 1 dash is this. But this time the polarity is different than here. So this is having now negative sign. So put here negative. And what about 1? So 1 is opposite. No. This is 1. So the 1 dash is this one. This is having positive sign. So 1 is having negative sign. Okay. This is 1. So this is having negative sign now. Earlier this one was having positive sign. Fine. Negative and positive. Let EMF induced again is E. Similarly, for coil 2, so where is 2? Positive. So right here positive, this dot is there, so positive, and 2 dash, cross is there, so negative, positive, negative, E. Similarly, what about 3 and 3 dash? So this is 3 dash, cross is there, so right here negative, so here positive. What about 3? So 3 dot is there, positive, and here negative, E. Similarly, check for 4 dash. So 4 dash is having dot. It means positive polarity, and 4 cross, that is negative polarity. So let EMF induced again is E and E. So from here itself we may observe that again the EMF across the terminals X and Y is E plus E, twice of E, again E. Check the polarities. So total 4E here in this parallel path, or from this parallel path also you can get E plus E plus E plus E, 4E. So here at this moment EMF induced across the terminals X and Y is equal to 4 times of E. Excuse me. Fine. One more observation can be done. Coil 1 at omega t is equal to 0 degree. See the polarity. One is having plus polarity, 1 dash is having negative polarity. Whereas at omega t is equal to 90 degree, opposite is there. One is having negative. This positive is now having negative, and this is positive. Similarly for 3, we have 3 dash as positive, but now 3 dash as negative. 3 positive, but here 3 negative. It means in the two coils, coil number 1 and 3, the polarity of EMF induced in the two cases, initial case omega t is equal to 0 and the present case omega t is equal to 90 degree, the polarity has been reversed. How? You may observe that these two coils 1 and 3 both have changed their location from south region to, this has changed from south to north and this has changed from north to south region. That's why the polarity has been reversed. At the same time, the connection with the terminals has also been reversed. You can check. See, for coil number 1 was connected with positive terminal, that is X. Now 1 dash is connected with X. 1 is connected to Y through this. Similarly for 3, we may observe that earlier 3 was connected with Y, but now 3 dash is connected with Y. So no need to worry. Whenever the polarities of EMF induced in the armature conductors or corresponding coils are reversed, at the same time, with the help of this commutator, the connections with the terminals are also reversed, so that the output EMF of same polarity, DC nature, is maintained across the output terminals. So this is the function of commutator, which helps in converting the alternating nature of EMF induced in the armature winding into a DC nature output voltage at the terminals. Fine. So for the from the three cases, we may conclude that if we are going to plot induced EMF and convert it to the output terminal, so terminal drop E, let us say terminal drop E, if we are going to draw, so mark here points E, 2E, 3E, 4E. Take here EMF E. Take E here and omega t here. So we have observed that at 0 it was 4E, so mark 4. At 45 degree it reaches to 2. Again mark here 45 omega t. Second case was 45 degree, this was 0 degree. Then at omega t 90 degree, and again draw like this first, then mark the positions. Like that. So this is 45 degree, again this is 90 degree, then 135 degree. So again add 45 degree, so 180 degree. So here again 225 degree, so 270, and so on, mark here. So 270 degree, so 315 degree, add 45 degrees, and again add 45 degree, so here it will be 360 degree, and so on. This is 2E. So we can see that for two-pole structure, this region is having magnetic neutral axis. So whenever a particular coil or number of coils passes through that magnetic neutral axis, so at that moment, particular moment, EMF induced is 0. That's why this dip is obtained. If we will increase number of coils, number of coils are increased, or number of poles are also increased. Suppose number 2 more pole will be there, north south like that. So corresponding we will get this shifted by this, right? So we may this, then this, one deep, then this, one deep, one deep. So this itself approximates a constant DC nature. So if we will increase more number of coils, so the approximation with the DC will increase. You can observe the speed of this rotor, that is frequency. So in one cycle, how many such dips will be obtained? You can observe, because we have taken just three moments: 0 degree, 45 degree and 90 degree. So in this we have observed that at 0 degree 4 is there, 45 degree 2 is there, 90 degree again this is there, and you may observe at your home, right? You can try. So in one cycle you may observe that such waves nearly equal to constant waves. If you will observe on a screen, you will see that the output waves are not alternating in nature but having the same polarity, right? So nearly the average value will be constant in nature, right? And that can further be make more smooth by increasing number of coils. Hope you understand the function of commutator. Now the most complicated part is waiting for you, that is winding design. I think that is the toughest part of any machine. So be ready for that. We will discuss, we will see, we will learn, we will enjoy. Hope for the best. Thank you very much.